Hey guys, welcome to your first video. It's a little late at night, so I might be a little quiet, so I put on my headset so you can hear me better. Also, I think the sound is just better. Anyway, so this is the way this is going to work. I'm going to post these videos with about 24 hours ahead, hopefully, and you'll have time to take notes, and then you'll take the notes and you will upload them into Google Classroom to get credit for that assignment. We're starting this because we're starting to get to places where you guys might need a little more help. I'm still not doing, not even close to all of the topics, just the ones that the majority of the class is still having issues with. So here we go. I'm going to take myself off camera and you'll just be able to hear my voice. You can't even see my eyes. I'm sorry about that. It's a reflection of the lamp at night. All right. Here we go. Actually, how do I take off this? There we go. Okay. All right, you guys. So the first topic that we're going to talk about is going to be classifying scaling isosceles and equilaterals by the length of their sides. So the names scaling, isosceles, equilateral kind of don't really, the only one that's really obvious is the equilateral. Lateral meaning side, equal meaning equals. So an equilateral has equal sides. Okay, a scaling is one where I'm trying to think of how you could remember this, because most of you have already learned this before. And if you're still struggling with it, it's not because you don't understand it. It's just because you forgot. So isosceles. I think I remember this one because of the SOS and the ELE. Well, that doesn't really make sense with the ELE, but the SOS makes me think of two sides are the same. And that's what an isosceles is. It's when two sides are the same. Scaling means no sides are equal. And it kind of sounds ugly, doesn't it? Like scales or something. I don't know. You can use your own way to try to remember them. But so this one, none of the sides are equal. So therefore it is a scaling. Okay, this one, it has a 45 and a 45 angle. What that means to you is that these two sides are going to be equal because this angle is congruent to that angle. It means their mouth, if this were like, these were teeth, right? These were teeth. The mouth would be open the same. Okay, this side and this side. So this is isosceles. Triangle. This one has all three sides, equilateral. This one, all three angles are the same. Again, that means that the width of the side on the opposite the angle are all going to be equal. So this one is equilateral. Sorry. Okay, here we go. This is supplementary and complementary. Again, I think this has to do with names. Okay. Do you remember supplementary and complementary? I sometimes think of complementary. It's like, hey, let's pay yourself a compliment. And let's say you're holding a mirror. I'm sorry, I'm not an artist. Here, this is you holding yourself. You're holding a mirror. Okay. And you're complimenting yourself. You're like, oh, you are so beautiful today. Okay. That is weird. Okay. I'm missing a nose. There we go. You're so beautiful. And you're complimenting, and therefore there is a 90-degree angle. Okay, complementary add up to 90, supplementary are 180. Okay, it says an angle measures 108. What is the measure of its supplement? That relates to supplementary. So you take 180 and you subtract 108 and you will get 72 degrees. All right, an angle measures 52. What is the measure of its complement? 90 degrees. 90 minus 52 equals 38 degrees. All right, moving on. This one, again, I believe this is more vocabulary than anything. Supplementary angles are angles that make a line. These would be supplementary angles. Okay? Vertical angles, I think of them as that they make a V. I mean, you could argue that all angles make some sort of V, but vertical angles are these angles and these angles. When two lines intersect, the opposite angles. So if you're going to name two vertical angles or supplementary angles, one pair of supplementary angles would be 2 and 4, 6 and 8, 1 and 3, 5 and 7. Or we could go with 2 and 1, 4 and 3, 6 and 5, 8 and 7. Get the idea? There's many. Okay, I'm going to take that off. Actually, I'll leave one. There's one set of supplementary for you. All right, so vertical angles. Here we go. Vertical angles. 5 and 7, 6 and 8, 1 and 4, 2 and 3. Any one of those pairs will work. Okay, next one. Find the perimeter of the following rectangle. Perimeter. I think of perimeter as like in cop movies where they're like, surround the perimeter. And what that means is the distance around. If you can just remember to go, peri actually means on the outside. If you think about biology, oh my gosh, I can't even think of a word. I was thinking of something with your skin. Anyway, peri means on the outside. Meter means measure. So measure the outside. I'd be happy if anybody wants to comment or come to class with a word with peri. That would be great. All right, so all you're going to do is walk around. Now, I'm going to show you something that I'm going to use in the next video quite a bit, and that is this. I'm going to ask you to do this a lot with area, perimeter, volume. You write formula, then you substitute the values of the formula, and then you find out what the answer is. Okay, I call it formula, substitution, resolution. So the formula for perimeter is 2 times the length plus 2 times the width equals perimeter. And that's what it's asking you, perimeter. So 2 times the length, plug it in. I'm going to plug in 3 1/10. 2 times the width is equal to the perimeter. Okay, you need to change this to a simple fraction or an improper fraction, I guess you'd call it. You go 10 times 3 is 30, 30 plus 1 is 31. And then this one is 2 over 1. Since they're both fractions, you can just do that. 6 over 4. Okay, this needs to go 2 over 1. Multiply that out. You're going to get 62 tenths plus 6 fourths. Actually, I'm going to reduce this. 6 and 4 are both divisible by 2. So I'm going to reduce it to 3 halves. And then I'll be able to find a common denominator. I think that it's the fractions that have you guys stumped a little bit. So 10 is the common denominator because both 2 and 10. 2 goes into 10 and 10 goes into 10. So this becomes 62 tenths plus 15 tenths. And that equals, I'm sorry, I'm going to have to erase this. Please make sure you copy it down, formula, substitution, resolution. Okay. Okay. 62 tenths plus 15. 62 plus 15 is 77 tenths. That means that goes in there 7 and 7 tenths. And you always need to put the units. Millimeters. Okay. Some people might do it like this though. 3 1/10 and 3/4. 3/4 plus 3/4 is 1 1/2. That's 6 2/10. You could add the 6 and the 1, you get 7, and you'd add the 1/2. It needs to go 5 tenths. 7 tenths. That's another way to do it. It's faster. And that's it for this video. Short and sweet. How do you like that?